Everyone. So in the last class we discussed how to write down the generating function, especially in the case of the problems of selection of R objects out of N objects. In this case we will see that how do we compute the coefficient of x raised to the power R from the generating function. So we are going to use the following formulas which you can quickly take a look. I am not going into the detail of the proof because they are quite simple. For example, the first one says that if I have 1 plus x square plus x cube, then I can write it down as 1 minus x raised to the power 4 by 1 minus x. The second one is simply 1 by 1 minus x, which is equal to 1 plus x square and so on. The third one is the binomial expansion. The fourth one is the special case of binomial expansion. Yes, where we replace x by minus x raised to the power n. The fifth one is interesting. I will discuss it, that why the coefficient here is r plus n minus 1 by r. And the sixth one is says that if there are two generating function, their multiplication would be same as the multiplication of two polynomials, and therefore if f and g are this, then the coefficient of x square would look like a2 b0 plus a1 b1 plus a0 b2. So here it is contributing x square, here it is contributing xx, and here it is 1 and x square. So let's move to the identity fifth. So if I have to use here the identity 2, then it is simply 1 by 1 minus x raised to the power n. Yes, both are equivalent. Now what does it represent? It represents the selection, unlimited selection with repetition, so which we discussed in the previous class. Yes, it means that if I have to write down it in the form of integer solution problem, it would look like this one. Now recall that in section 5.4 we have discussed that, or before that we have discussed, if we consider the problem of selection of R objects without repetition, it is NCR. But if we are considering the selection of R objects with repetition, then it is CR plus n minus 1 comma R. It means that in both of them the coefficient of x raised to the power R is CR plus n minus 1 comma R. Yes, so very important, please remember it. Now let's see some exercises. The first one says that find the coefficient of x raised to the power 16 in the given generating function. Yes, first let's see what does this generating function represent. Yes, so it represents that there are 5 boxes and each box has at least 2 balls, because it starts from x square and it is the problem of unlimited selection or unlimited repetition. Yes, so now let's see algebraically how does it works. For algebraically, I take x square common, so it become x raised to the power 10, then 1 plus x square, so on raised to the power 5, which is x raised to the power 10 and 1 by 1 minus x raised to the power 5. So this is identity 5 which we have just discussed. So here the problem get transformed into looking for the coefficient of x raised to the power 16 is equal as coefficient of x raised to the power 6 in 1 by 1 minus x raised to the power 5, which is CR plus n minus 1. So C6 plus n is 5 boxes minus 1 comma 6, which is the required answer. Yes, but if you see what exactly has happened is that to address the problem, you took x raised to the power 10 common, which means you have taken combinatorially 10 balls outside. And what does it represent? It represents that from each box, because each box must have at least 2 balls, so you first put 2 balls in each of the boxes, and then you distribute the remaining 6 balls with repetition into 5 boxes. So this is the combinatorial explanation, but you can see that algebraically it has been done automatically using the concept of generating function. So let's see one more example. Use generating function to find the number of ways to collect $15 from 20 people if each of the first 19 can give a dollar or nothing and 20th can give nothing, $1 or $5. Please do try to write down the generating function first. So for first 19 means for each person, what is the possibility? Either 0 or 1. So either 0 or 1 means x raised to the power 0 and x raised to the power 1, and it is get repeated for the 19%. For the 20th it is 1 plus x raised to the power 5. So this is your g of x. Yes. Now in this g of x, let's say that the coefficient in first function represented AR and here it is represented as BR. And what I have to find? I have to collect $15. So I am looking for the coefficient of x raised to the power 15 in g of x. Now if you see the second bracket, there are only 3 terms. So you can say b0, which is x raised to the power 0, b1 and b5. And here there are so many terms, a0 plus a1 and so on. What I am looking for, if I choose b0 from there, then from the first bracket I need a9, a15, because the coefficient of x raised to the power 15 and x raised to the power 0. Then if I choose b1, then from there I need the coefficient of x raised to the power 14, because b1 is the coefficient of x raised to the power 1. In total it gives you the coefficient of x raised to the power 15. And if I choose b5, then I am looking for the coefficient of a10. Now the problem gets easy. So the first one, coefficient of b0 is 1, and the coefficient of x raised to the power 15 in 1 plus x raised to the power n, which is a binomial expansion, is 19c5. In the second case, I need the coefficient of x raised to the power 14 from this bracket, so it becomes 19c14. And in the last case, I am looking for the coefficient of x raised to the power 10. So this is how we get the coefficient of x raised to the power 15 in the generating function. Now again we can quickly discuss that what does it combinatorially represent. If we see the answer, can you give its combinatorial explanation? So there were 20 people, but you can see only 19 is visible here in all 3 brackets. We are choosing something from the 19 people. It means that we already assumed 3 cases, that there is one person who either contribute 0, contribute 1 or contribute 5. These 3 cases are there. It means from the remaining 19 people, either I need to collect $15 or $14 or $10, and then the addition principle come into the picture because there are 3 cases. So this is the combinatorial explanation. How many ways are there to distribute 25 balls into 7 boxes if the first one can have no more than, so first one is at most 10 balls and any number can go in other 6. Again, quickly try to write down the generating function. So the generating function is 1 plus x raised to the power 10, and anything can go into the other 6. Yes, so other 6 means that 1 by 1 minus x raised to the power 6. Now you can see that I am looking for the coefficient of x raised to the power 25. One way is that I consider all these 10 cases. So from here I can consider a0, a1, a2 till a10, and then based on this, for a0 I should consider b25, then for a1 b24, and so on, and in the end b15, and I found. So there is a lot of calculation. If I use the another identity, then it's better to write down the generating function in this form: 1 minus x raised to the power 11 by 1 minus x, and this is 1 minus x raised to the power 6. So it becomes 1 minus x raised to the power 11 and 1 minus x raised to the power minus 7. So now you can see that it becomes 1 minus x raised to the power minus 7 minus x raised to the power 11, 1 minus x raised to the power minus 7. So now from here I need the coefficient of x raised to the power 25, which is 25 plus 7 minus 1, 7 boxes are there, and 25 minus x raised to the power 11 is already there. So it means that I need the coefficient of x raised to the power 14, which is 14 plus 7 minus 1 and 14. Now what is its combinatorial explanation? So first bracket shows that the all possible ways to distribute 25 balls into 7 boxes, minus we consider that the first box has at least 11 balls. So at least 11, so we put 11 already, and the remaining 14 need to be distributed in the 7 boxes. Okay, so this we have already discussed. How many ways are there to select 25 toys from 7 types of the toys between 2 and 6? If you try to solve it combinatorially, it becomes quite difficult, but you will see that using generating function it's very easy, because writing down the generating function is simply this, and 7 types are there, which is x raised to the power 14 and 1 plus x raised to the power 7, which means that I am looking for coefficient of x raised to the power 11 in 1 minus x raised to the power 5 by 1 minus x. This is how it can be written. Yes. So x raised to the power 14 already gone, and this becomes 1 plus x, and sorry, whole raised to the power 7. So this becomes 1 minus x raised to the power 5 raised to the power 7, and 1 minus x raised to the power minus 7. Now for the first bracket I will use the binomial coefficient, where the first term would be a0, then there is one term which is minus a5, and there is one term which is a10. After that a15, because I don't want the coefficient of x raised to the power 15, so that would not come into the picture. Yes, so if a0 means x raised to the power 0 is there, and I am looking for the coefficient of x raised to the power, so I need b11 here, I need b6 here, and I need b1 here. Yes, now a0 is 1 and b11 is 11 plus 7 minus 1, 11, then minus a5, so which is 7c1. So 7c1, go back to the page of the identity if you do not recall it, and then the coefficient of x raised to the power 6 from this bracket, which is 6 plus 7 minus 1 and 6, and plus 7c2 coefficient of a10 from here, which is the third term. and then the coefficient of x raised to power 1 from here. So 1 plus 7 minus 1 and 1. So this is the required answer. Using generating function, verify the binomial identity. So this one is quite simple, but we have to use the generating function. So only thing to identify is that how does the generating function looks like. So the right hand side is selecting n objects out of 2n objects without repetition. So binomial function comes into the picture. So 1 plus x raised to the power 2n, and it is the coefficient of x raised to the power n in 1 plus x raised to the power 2n. Yes. Now if you see the left hand side, then it is like, for example, NCR square. So in the coefficient of x raised to the power n in 1 plus x raised to the power n, 1 plus x raised to the power n, so in this one it is NCR, and in this one, since I am looking for the coefficient of x raised to the power r, so it comes out to be NCn minus r. So from the two brackets, from the two brackets, when you need the coefficient of x raised to the power n, then from one bracket if you choose x raised to the power r, in the other bracket you have to choose x raised to the power n minus r, and they both multiplied gives you the coefficient of x raised to the power n. Now NCR and NCn minus r is same as NCR whole square, which we have already discussed, and this justifies the left hand side. So let's discuss the last question. In how many ways can you fill a bag with n fruits such that the number of apples must be even, bananas must be a multiple of 5, there can be at most 4 oranges, and there can be at most 1 pear. Now combinatorially it is extremely difficult, very difficult to address, but using generating function it's very easy. So the generating function is even number of the apples, so 1 plus x square plus x4, so on. Bananas must be a multiple of 5, so 1 plus x raised to the power 5, so on. Oranges goes till x raised to the power 4, and pear goes to 1 plus x. Now for the first and second bracket, recall the binomial identity 1 plus x raised to the power n. Recall that 1 by 1 minus x, which is 1 plus x square, and so on. So this is 1 by 1 minus x square, this is 1 by 1 minus x raised to the power 5, this is 1 minus x raised to the power 5 by 1 minus x, and this is 1 plus x. It gets simplified to this one. Now I need the coefficient of x raised to the power n. So in this one we know that it is r plus n minus 1, so r is n here because I am looking for the coefficient of n. So n plus 2 minus 1 and n, which is cn plus 1 comma n, which is cn plus 1 comma 1, which is n plus 1. So in n plus 1 ways this distribution can happen. So you can see that using the generating function the problem is very easy to address in comparison to the combinatorial techniques. Thank you.